Never see me call.
Okay, that's not my concern. Can it see or not though?
Okay. Gender difference, you all know that it's independent sample t-test. Okay, so I don't have to go through the steps, right? You all know the steps, right? Analyze, compare means, independent samples t-test, weight is your DV, gender is your IV. Always remember that you need to define the groups according to the numbers you have used to indicate each category. So in this case, 0 was for male, 1 was for female. After keying in the numbers, you click continue. Right, then you click OK. And this is basically what you get. Right? Okay, tell me, how should I interpret this? How should I interpret this? What is the degrees of freedom that I should be reporting? What is the degrees of freedom that I should be reporting? What is the degrees of freedom that I should be reporting? The degrees of freedom that I should be reporting is 10.94. Because there is a bias in the sample. Bias in the sample because this is less than 0.05. So you cannot assume that there are equal variances. You have to assume that the equal variances are not there. And so you report this one. The t-value is the same, but it is the degrees of freedom that makes all the difference. And in this case, the p-value is also different. Now, one more time. Okay, after you have run your independent samples t-test, remember I told you that they actually have to check for errors in your sample, yes? Right? If the errors are too much, it basically means that there are differences amongst your subjects. Okay? And those differences actually then cause your sample to be a biased sample. So they actually do a check before they actually run the t-test, as it were. This test is actually the Levene's test for equality of variances. If this p-value, now this p-value is the p-value associated with the Levene's test. This has nothing to do with the t-test, you understand? The t-values themselves, they have their own p-values, which is here. This p-value is only associated with the Levene's test. And this p-value is what you see to get an indication of whether your sample is a biased sample or not, whether there are differences already. If it's 0.05 or less, it basically means differences exist amongst your participants even before you do any inferential analysis. That means there are a lot of sampling error. It basically therefore means that your sample is biased if this is 0.05 or less. So if this is 0.05 or less, you have to read off what we call equal variances not assumed. Equal variances not assumed because you cannot assume that they're the same because you already shown that there are errors and therefore your subjects are different from each other. So you need to read off the t-value that's associated with the equal variances not assumed, report the degrees of freedom associated with that, and the p-value associated with that. Can, if this had been more than 0.05, then you read off equal variances assumed. Then you can read off the top where the degrees of freedom then is 16. Got it? Yes. Say again, sorry.
The p-value is not significantly skewed, but under the business maps, right? The p-value.
This one.
We write this.
This one.
She's asking which one should she write? Which p-value?
Okay, one more time. Now this p-value is just associated with the Levene's test. You look at this only to help you to decide is your sample biased or not. And that will help you to decide should you read off equal variances assumed or equal variances not assumed. That's all. You don't report any of this thing here. You don't report any of this. This is only to help you to decide should I read off the first row or the second row. You understand? 0.05 or less, you read off the bottom row. More than 0.05, you read off the top row. When you report the t-test, the appropriate p-value to report is actually this one. Okay? Can? Alright? Okay, so just look at the PDF, right? Again, we will, or I will give you the hard copy of the reporting stats. You just follow the format and then you just plug in the values.
So how important is that point?
Okay?
Okay.
Okay? So run the appropriate test to find out if there are gender differences. So the very first thing that you want to do, and this is thanks to Jia Hao. Okay? Based on what he told me yesterday, I have decided this is what you should write.
Based on what you told me yesterday, it's solid.
Oh, yeah.
Basta. Basta.
Okay? For number 4, 4A. Run the appropriate test to find if there are gender differences in post-intervention weight and report the statistics in ATA format. So the complete thing that you ought to write, there is no significant gender difference in post-intervention weight, comma, T bracket 10.94 equals to point minus Okay, minus 0.97, P equals to 0.353. Okay? Okay? Alright, so this would be the complete answer to 4A. Okay, then 4B, interpret
Gender, that's not.
Okay, let me just plug in the values.
I mean, like, the first sentence are saying the same thing. I guess now we have to put in the full sentence.
Okay. Yesterday when I put that one, then you see how come the long sentence, I decided you're right. Why don't you want the whole thing?
Dang it, I'm not gonna write sentences for both.
Wait, what?
Okay, can?
It's like the same thing with both sentences.
Exactly.
I would have just gone for the thing, but then since you say that, I said okay, I can.
So that's report, that's below the interpretation.
Yeah. So this is basically, hang on, so this is for A. This is for
No, we have to write the sentence.
Okay, 4A is run the appropriate test to find if there are gender differences in post-intervention weight and report the stats in APA format. So 4A is there is no significant gender difference in post-intervention weight, and then the T thing. Okay, the most important thing of course is this one, right? The most important thing is this one. The most important. Okay? And then when I ask you for the interpretation, which is 4B,
Oh. Nice one. Yeah, he did.
post-intervention weight for males was not significantly different from that for females. Okay, and the mean and standard deviation, of course, you get it from here. Okay. Okay. It's easier for me. We can. I need to come up with a rubric. So this one is actually for the moderators. Can? Okay, now for number 5. Okay, now number 5 is actually analysis of variance. Okay. Okay, so analysis of variance, this is what you do. Okay, so you go to analyze, you go to compare means, you go to one-way ANOVA because this is between subjects. Okay, and then you put in your dependent as weight, you put in the supervision as your IV. For this one, remember the post hoc, Bonferroni, options, descriptives, right? And then you click OK. Right, and of course this is the results. Okay, so 2,15 F bracket 2,15 equals to 0.316, P is 0.734. Alright, so 2,15 F bracket 2,15 equals to 0.316, P is 0.734. Alright, so 2,15 F bracket 2,15 equals to 0.316, P is 0.734. Alright, so Okay, on the day of the test, you will write your answers on the test paper itself and you submit, you give it back. There will be places for you to write. Huh? Yeah, right then how?
Type.
Yeah, yes, Sharon. Can I repeat what? Okay, can. Okay, so for this one, because supervision type in this case is between subjects, right? Right? So different people go through no supervision, another set of people go through peer supervision, and then another one goes through clinical supervision. So this is between subjects, so you go to analyze, compare means, one way and over. Dependent list here is of course your post-intervention weight. Your factor here refers to your independent variable, in this case is the type of supervision. Right, so put in the post-aid. Okay, post-weight it goes here, supervision goes here, post-hoc, Bonferroni, continue, options, descriptive, continue, then you click OK. Okay? Sharon? What cannot? Non-verbal cue, you sure? Okay, so again, now one more time, it's like you go to analyze, compare means, you go to one way and over, your dependent list is your weight, the factor is your IV. The reason why we need to go to post-hoc is because you have more than 2 levels. If there's any significant effect, you need SPSS to tell you the significant differences comes from between which 2 levels. That's why you need to tell them to compare the levels. Okay, that's why you go to post-hoc, and that's why you go to options as well and ask them to generate the means. Alright? Okay, so that part is conceptual. Alright, the part is conceptual. So you have to try to get the conceptual part before this analysis can make sense to you. Alright, so in this case, like I said, there is no significant difference, and so then 5A would be this, right? This is 5A. And then 5B, you interpret the results.
Depends on how much data there's a key.
Yesterday I took 30 minutes to figure it out.
This one actually okay, oh, was that really good?
Over. I know, really not understand.
Surely you're in 3
Yeah. So and then
it's like if you like check every time it's like you just run out of things.
because it gets confusing the second number. Like I sent you my
Okay, so this is then 5B, the interpretation of the results, right?
So I press down.
Okay? Alright, so post-intervention weight did not differ significantly between intervention with no supervision, peer supervision, and clinical supervision. That's it. And then you report the means and standard deviation. Okay? Alright, I know it's a lot, but basically this is nothing new. Just going through this. Again, right? It's nothing new. You have gone through this yesterday. Okay? And the time before that, I'm just reinforcing this. Okay, I know it's a bit of a drag. Okay, but the more I enforce, even if you don't understand, hopefully something will get through. Alright? So, this is basically what you need to do. Alright, and very quickly, I'll just take a look at the other. Alright, if let's say you have 3B, right? Practice 3B, where now you have within subjects. Okay, now this is a bit of a trick. Alright, this is going to be a little bit more tricky. So let's take a look. Alright, so okay, so essentially I am just gonna what the hell? Okay, now if it is within subjects, then there's only 6 people. All 6 go through all 3 conditions. Okay, just now was between, so 6 in each condition, 6 times 3, 18. But this is within, and this is how it looks like. This one, if it's within, is basically taking whatever you see, and just putting everything wholesale. Right, whatever that appears here is actually all here. This is all wholesale. The only thing that you need to create is gender. Got it? Alright, so in this case, if we go through the same questions, which is basically it, right? Find the mean, median, range, and everything for each condition. Now this one, it's very straightforward. Analyze, descriptives, you just go to frequencies, and then you just put in all 3 stats. It's all here. Continue. Okay. There you go. Because this is within subjects, the way you key in is by columns. So the columns are already created. So you just, when you run the mean, standard deviation, everything will just come out like this. You just select everything inside. Right? So to this extent, this is a little bit simpler. Okay? Okay? So that takes care of 2A. Now by gender. Okay? Very similar, right? Analyze, compare means, essentially all your weight here goes into the dependent list. Sex is independent. Click OK. Males, females, superior, clinical, all the mean, standard deviation are all there. So it's a little bit more straightforward. Can do? Yeah. So again, compare means. You just throw in all your dependent measures here. The weight under no supervision, the weight under peer supervision, and the weight under clinical supervision. And then your gender is an independent list. Just click OK, and this is what you get. You report according to gender. Right? Condition no supervision for males is what? Condition peer supervision for males is what? Condition clinical supervision for males is what? This is actually the next one, right? Which is here. It's 3B. 3. Number 3. Number 3. Can? Okay, 4A doesn't make sense. Does it make sense? Yes, it does make sense. Post-intervention weight. Okay, there's an error in this.
I think the part A and part B is
Okay, there's an error in this one. Okay, so this one, ignore. At this point in time, you have to ignore this one. Because if you try to run it, you can't. Gender difference is a key test. You can put everything in, and everything will be 1 dV. Okay? But the reason why I say it's wrong because I have to specify. So what it does is it runs the t-test looking at gender differences for weight under no supervision, for weight under peer supervision, and for weight under clinical supervision. They look at each and see if there's any gender difference. Okay? That one you ignore first because that one is not something that is intelligible. Okay, but this is how you do it. Okay, more importantly, the within subjects and over. Okay, which is the last one, number 5. Okay, it's analyze repeated measures. Okay, this would be your weight. There are 3 and 9. Okay. Alright, and options.
no. This is oh, this is
Okay, one more time. The last question. Alright, the last question, which is number 5. Run the test to see if there are any differences in terms of supervision type. Okay, now this is of course within subjects, right? So within subjects, you need to go to analyze within subjects and over general linear model, repeated measures. Right, this is within subjects and over general linear model, repeated measures. You first have to define that particular thing you're looking at, which is weight under supervision. Right, there are 3 levels of that. You add it in, then you define what those 3 are, and basically it is pretty simple. It's just these 3. Okay, gender doesn't come into play. You're just looking at, is there any difference between the post-intervention weight under no supervision, peer supervision, and of course clinical supervision. Alright. Click on options. Ask SPSS to compare the different levels for you. Descriptives. Click continue. Click OK. Okay. Okay, you will get this one. Okay, here, this one. Okay, so there is a second difference in this case. You read off sphericity assume because if you take a look, this is more than 0.05. If this is more than 0.05, it basically means that there are no sample bias. There's no bias in the sample if this is more than 0.05. So you can assume sphericity. So you read off the F value here, reporting the degrees of freedom 2 associated with the IV, and 10 the degrees of freedom associated with the error. Okay, so F value is 6.91, P value is 0.013. So it is significant. Then you look at the pairwise comparison. Here. Okay, the data is a bit off. Okay, but it should be, there's a difference between actually 1.3 and 2.3. Okay, but in this case, like I said, the data is not perfect. There's some issues with the numbers. Okay, by right, this should be less than 0.05. Okay, so let's assume that this is less than 0.05. Then the difference you report is between clinical supervision and no supervision, clinical supervision and peer supervision. Right, the difference is there. Okay, the mean is here. Okay, so the greatest weight loss is when there is clinical supervision. So clinical supervision significantly lower than no supervision, significantly lower than peer supervision. Okay. Right now, essentially, okay, all these things are what you have done yesterday. We have gone through this yesterday, and to some extent, we've done this also previous week as well. I think the most important thing to remember, if you cannot remember all these other stuff, is this. Okay, your test will be scenario based that resembles something like this. You have to take a look at the scenario, and the very first thing you have to decide is if the scenario is describing a study that is between subjects or within subjects. Okay, the point of me sharing this additional data practice set with you today is to tell you this, okay, and to show you how I can set two different papers with exactly the same data set with almost identical description, but what I vary is certain descriptions, okay, like this, as compared to this. Alright, so everything is the same except for some minor descriptions or small descriptions in the scenario, but those minor changes are actually very important in helping you to decide whether it's between or within subjects. Right, so the purpose of me showing you this is really to alert you, okay, to pay attention to the scenario, to decide whether it's between or within subjects, because then that will determine how you enter the data. Right, so if it's within, you can just transfer wholesale. Okay, but if it's between, then you know that you have to create not only a column for gender, but you must then create a column for the type of supervision. And then you have to have the different levels where you have 0, there's no supervision. Okay, 1 is when there is peer supervision. And then 2, when there is clinical supervision. Okay, and then you have to then key in accordingly whether it's no supervision, with supervision, peer, or whatever, depending on what you are given. And do? Yeah, no?
Yes.
Okay, and then depending on which one, I guess the other learning point that is new is this. How do you generate the mean, standard deviation, the range? It's really here, right? Analyze, compare means, right? And then you just throw in the dependent variables here and the independent variables here, right? Select whatever you need. You click continue and everything, and then you get the necessary output. Okay, right, things like this. Alright, so like I told you, this is really, like I said, it bears close resemblance to how a test would look like. And the questions are also close resemblance. And the idea here is once you're able to enter the data, find a mean, median, standard deviation and everything, and you get everything right, then you would have passed the stats test. Okay, so minimally, if you want to pass, you must know how to run this. Okay, then if you are able to do the other two, of course those are inferential statistics, then of course you can score. Okay, one last thing that I need to tell you. There will be one conceptual question. Okay, I went back and took a look at the test paper. There is one conceptual question. The conceptual question will come from the methods lecture. Okay, I will tell you where to study. This is where you need to read all the way up to okay, the quantitative research methods. Read this one. Just read this section. Just read this section. So slide 104 on my screen, right up to 114. That's it. Read that part for the conceptual question.
Read quantitative research.